Hi guys. So having seen the sum, okay, generally people think that this problem is complicated and it's a bit complex and it's difficult to crack. But today I'm going to tell you the secret that makes this sum super easy. Believe me, just be there with me and we'll be able to solve this easily. Alright. So how should we go ahead? At the beginning, what I can feel is that this can't be changed. Should we go with the denominator? I think the simplification of the denominator would lead us to further simplification so that we'll be able to figure out how we can match up with the right hand side. Okay guys, so let's get started. So x plus y plus z, okay, x to the power of minus 1 can be written as 1 upon x. This multiplied by y to the power of minus 1 can also be written as 1 upon y. There's a plus sign here, remember guys. So 1 upon y, and for this, okay, 1 upon z, for this 1 upon z, and okay, dot 1 upon x. So this we have to prove to be equal to x, y, z. What next? Can you think of? Chalo, grab a pen and paper and we'll solve it together, okay, step by step. So x plus y plus z. What next? This can be written as xy, this as 1 upon yz, this as 1 upon zx. Alright. Next, what do you think? So, I'm sure you understand that xy, yz and zx, okay, are the denominators. Hence, we need to find out the LCM of these denominators. What should be the LCM of xy, yz and zx? Any idea? Of course, it will be x, y, z. Okay. I'm sure you have done this in the lower classes and you know how that goes. Okay, we have to find out the factors, okay, of x and y, y and z and x, and then we make loops and try to find out the LCM. Since we have xy here already, so which means, okay, xy is already here, so we write z. Some people call it z. So you may call it so. YZ is here, so there will be x here, correct? And ZX is here, so you can write Y. Alright guys. Next, we have x plus y plus z. Remember, this is the numerator I'm talking about. Okay. And here below x, y, z can be written in alphabetical order. So x plus y plus z divided by, okay, what? X, y, z. Correct? So whenever we have this as numerator and this as denominator, generally we divide, isn't it? So when we divide x, y, z divided by this, okay, x plus y plus z divided by x, y, z, we need to, okay, flip this and write it topsy-turvy. X, y, z on the top and x plus y plus z below. Got it? So here we have x, y, z. So this entire thing sums up or ends up being XYZ. Therefore, LHS, which is this entire thing, is equal to RHS. Have you understood, guys? So wasn't this very simple? So next we are going on to the next question of the same kind, and I hope you people have understood this. Okay, any queries regarding this, okay, will be dealt in the comment section if you are eager enough, okay, over any point on this. If I have to reinforce, I can tell you, take this. All right, first, next we bring them down, straighten up this two, and then we try and multiply them and have them together as respective denominators, after which we try to find out LCM of x, y, y, z, zx, okay, here. So this one should be here, right? So x, okay, y and z. LCM x, y, z. So generally what we do is we try and find out what is missing out here, and that we write it on the top. Okay, the same thing I did here too. And there we have x, y, z LCM. This has x plus y plus z, the numerator thingy, and then we have at the bottom too, having reassembled, we have x plus y plus z over x, y, z. Okay, when we divide this stuff, this is the entire denominator. We get them flipped in the next step, and this gets cancelled with this. Therefore, we have x, y, z. So I hope this is crystal clear with you all, guys. So this was the trick I was talking about, and in my next question we'll have something more interesting similar to this. Alright, guys, so wait and watch.